Welcome, class. We're going to start off with a review from what we did yesterday on integers and fractions. Here's a review sheet for you two. All right, let's go over this sheet real quick. Who can tell me what an integer is? Go ahead, Sarah.
It's a whole number that includes negatives, 0, and positive numbers.
Good job. Can you give me an example of what an integer would be?
Like 1,
Right, just a number. Go ahead, Carrie. Can you give me another example?
2.
2 would be an example. Also, like negative numbers, like negative 1,000, or like you said, 0. All right, Carrie, can you read what a fraction is? What was a fraction?
Not a whole number, a part of a whole or a ratio between numbers.
All right, Sarah, can you give me an example of what a fraction would be?
Like 1/2.
1/2, right. All right, Carrie, can you give me another one?
7/8.
7/8, and also you can also do negatives. So, for example, negative 4, right, because you can put a 1 underneath a whole number, or let's say negative 3/4. Also, don't forget that repeating decimals, such as 0.3333 repeating, can also be a fraction as 1/3. Now who can read the next statement? In a fraction, what happens when the 0 is a denominator?
It's called being undefined.
Right, Sarah?
It doesn't have an answer. Like, it can't have it.
Right, so an example would just be any kind of number, like 5 over 0 would be undefined, and so you can't have that. Alright, so what we're going to talk about today is called a rational number, or what rational numbers are. So here's the definition of rational numbers. You guys can reference this. Carrie, can you read that for me? What's a rational number?
A number that is a fraction of integers where the denominator is not 0.
Alright, so this has 3 parts. A number, so first of all, a rational number just has to be a number, first of all. It has to be a fraction of integers. So we just went over what an integer was and what a fraction is. So it has to meet those 2 conditions, and also the denominator cannot be 0. So if it meets those 3 conditions, this is a rational number. So I'm going to give you a couple of examples and see if you can tell me or not if this is a rational number. All right. So, Carrie, is this a rational number, 1/2?
Yes.
Why? Why is it a rational number?
It's a number. It's
Right.
a fraction of integers.
What are the integers?
1 and 2.
Right, okay.
And it is not a denominator. It does not equal 0.
Right. It would be equal what? What's the denominator?
Like, it's 1
Denominator
and
is
2.
2. The denominator is 2.
Right.
Good job. All right, Sarah. See if you can do one here. How about this one? Negative 3/7. Is that a rational number?
Yeah.
Yes. Why? Why is it? Why do you think it's rational?
Because 3 and negative 7 are numbers. It's a fraction of integers. The integers can be negative.
Right. Right. Exactly.
And the denominator is not 0.
What's the denominator?
It's 7.
Right. Good job. All right. We'll do a couple more. All right, Carrie, is this a rational number? This is where it does not repeat or does not terminate. It just keeps on going forever.
No.
No, why?
Because it just keeps going and going and going forever.
Right, is this a number?
It's a number.
Right.
But it's not.
Can it be represented as a fraction of integers if it keeps on going forever and ever? No.
Not truly.
Right.
It's pi.
Right, it is pi. Very good, Sarah. All right, Sarah, one more here for you. The square root of 5. You think that is a rational number or not?
No.
Why?
Because it's square root and if you square root it, then it's,
What happens to it if we?
it goes on and on.
Right, it goes on forever.
Repeating.
So then what condition does it not pass?
The fraction of integers.
Exactly right. Good job. All right, we're going to work on, so those are rational numbers. We're going to work on a strategy from a lady named Laura Robb in her book called Teaching Reading in Social Studies, Science, and Math. All right, and this strategy is about reading, and we're going to use it in our math class today. We're going to do some word problems. So the strategy goes like this. I'm going to read this word problem on the computer here. And it says, Johnny goes to a bowling alley where they don't have the normal shoe size. So Johnny wears shoe size 8, but he can wear a little bit bigger and a little bit smaller shoes. Give any rational number shoe size between 7 1/2 and 8 1/2 that he could ask at the bowling alley. Now I'm going to try and retell it to my partner without looking at the problem. So if I can try to retell it to you, I'm gonna say, ah, man, I think there's a guy named Johnny, and he's going to a bowling alley. He's gonna bowl. Something about shoe sizes. I have to pick something, and I can't remember the whole problem. So let me reread it again, out loud, and also to myself, and then try and retell once again. Johnny goes to a bowling alley where they don't have the normal shoe sizes. Johnny wears a size 8, but he can wear a little bit bigger and a little bit smaller shoes. Give a rational number shoe size between 7 1/2 and 8 1/2 that he could wear to the bowling alley. Alright, so there's Johnny, he's going bowling. They don't have the right numbers, so I have to give a rational number, like we talked about, between 7 1/2 and 8 1/2 of a shoe size that he can wear. So see, I know that there are a lot of rational numbers between 7 1/2 and 8 1/2. I'm just going to choose 8, because you can put a 1 underneath, and that's a rational number. Because it's a number, it's a fraction of integers, and it's also a denominator. This is not 0. So I'm going to have you two pair up, and you guys are going to do the next one together. Alright, are there any questions? Alright, so after each one, after you reread it, and try and retell it, if you need to, reread it again, and then retell it, and then you guys can solve it together, alright? And each will do one here. Go ahead, Sarah, how about you try and read and retell that one?
Will we read out loud?
Yeah, read it out loud, please.
Julie is doing her math homework about long division. When she gets her answer, the numbers after the decimal just keep going and going. They never repeat. Did Julie find a rational number when she did the division? Why or why not?
Alright, now try and retell Carrie without looking at it.
Something about Julie wanting to find, like, she's dividing and wanting to know if it's a rational number.
Alright, so that's not quite enough information. Try and reread it again and retell it.
Julie is doing her math homework about long division. When she gets the answer, the numbers after the decimal just keep going and going. They never repeat. Did Julie find a rational number when she did the division? Why or why not? Okay, so she's doing division, long division, and wants to know if it's a rational number, but the numbers don't repeat. They like go on forever and ever. Like pi, which means no, it's not a rational number.
Good job. Now why again from our conditions this does not pass?
Because if the numbers go on and on forever and never repeat, they can't be put in a fraction.
Right. Alright, good job. Carrie, we're going to try you on the next one here. Go ahead and read that one.
Joe has 36 brownies to share in his class. There are 12 people total in his class, and he wants to divide all the brownies among the class. If Joe divides the brownies up, will he have a rational number? If so, what is the number? Joe has brownies, and he wants to give them away. I remember this.
That's alright, you can reread it. Read
Joe
it.
has 36 brownies to share, and there are 12 people in this class, and he wants to divide all the brownies among class. If Joe divides all the brownies up, will he have a rational number? If so, what is the number? Yes, because 12 divided by 36 is 3, and 3 can be put over 1, so it's a fraction of integers.
Right, okay, it would be 36 divided by 12 is 3, but you got the number right.
Oh, 36 divided.
Right, and 3 over 1 would be a fraction of integers, also a number.
Right, and it's not over 0.
It's not a denominator. Alright, good job everybody. Alright, I'm going to ask you a couple follow-up questions here. How can rereading and retelling help you understand a problem like this?
It helps me understand it better because I forget things easily.
Right, exactly how you say.
Like the parts that like you don't understand, like they're confusing.
Right.
Like if you read it over and over, like you just kind of get what they're talking about.
Yeah.
You get it.
Exactly. So it helps you understand. It helps you understand every part of it and to be able to solve it better, right? You can understand it and solve it better. All right. Can you use this kind of technique, rereading and retelling somebody else what you tried to read? Can you use it just in math, or can you use it in something else too?
You can use it in literature.
And like, great, reading
Telling
stories or something like that. What you
Or
say?
like vocabulary, like just the context of a word. If you keep on reading that sentence or the past whatever it's in, then you kind of get what it means.
Right. You can do it with almost anything that you read. You can try and read it first, retell somebody else, read it again if you need to, and then move on if you have to. All right. So to close up the class today, let's all say together: what is a rational number? What did we learn today?
A number that is a fraction of integers where the denominator is not 0.
All right, good job, guys. We'll pick up with this tomorrow and maybe go a little bit further with some more word problems and maybe a little review. Thank you.